All right, guys. So, I think the orientation is being messed up for some reason. So I'm stuck like this. But hopefully, it should be good. All right. So I broke this up into 6 different questions that are all be featured tomorrow. Remember, tomorrow is 6 written questions. So I've kind of one of each. We'll break them down into their subcomponents, some of the different ideas that they involve, and obviously their answers or their solutions. We'll give everyone a minute or two to catch up. I would recommend having a calculator, a piece of scrap paper, and if you want to get started on the questions on the screen right now, go ahead and do so. Like I said, we'll wait a minute or two, probably around 6:36, and I'll start going over this. As a side note, if anyone knows why it's locking orientation, that'd be awesome. Because I have no idea why. Has to do with how you start it. No, I don't have the lock on. Yeah, check that. It's not letting me for some reason, whatever. It's not in the settings. Weird. Let me try it one more time. Yeah, orientation lock. What the heck? All right. We'll make the best with what we got. Said we'll wait another minute or two if you want to go ahead and get started on this one. No, this is just for Algebra 1 today. 6th graders, maybe for a future test, but I think there's more geometry people in here than people in my homeroom, which is weird. No, there's like 822 people in here. Okay. So we're gonna get started. This is a straight up elimination method question. I would not recommend using substitution. Notice how all the coefficients, are not 1, I should say. They're all something. That would make a good candidate for substitution. However, we don't have that, so we'd have to divide or get messy with fractions and stuff like that. Also, notice how this is kind of nicely arranged for us because it is lined up. Now, what do I mean when I say that? Notice how x is stacked on top of x, y is stacked on top of y, and we have our equal signs lined up and then some number on the right. Sometimes we've seen that on a previous test, I believe. X and y were kind of flip-flopped, and it caught a lot of people because they just jumped right into elimination. So always make sure it's lined up previously, or before you get started, I should say. Now, you do have some choice here with how you solve this. You could eliminate your x's by choosing a common multiple. Not necessarily a least common multiple, it's usually a good idea, but any common multiple will do, and creating an additive inverse. Or you could eliminate y's by seeing what 8 and 12 both go into. I'm going to choose x here, so I'm going to create For 5 and 3, I know that they both go into 15. So I'm going to make the top one positive 15 and the bottom one, great start. I'm going to make the top one positive 15 and the bottom one negative 15. Now it's important that they're inverses, so notice one is positive and one is negative. And I'm going to write my new multiple to the right here, which hopefully you guys can see. So that should be 15x plus 24y equals 21. Down below, we see we're going to get negative 15x minus 60y equals positive 105. So now notice how I have an additive inverse. This is my new two equations. And they are identical to the original equations, so it's not that we changed anything, we multiplied it throughout. That's very important. People usually forget these numbers on the right-hand side. So if you keep them the same, odds are you made a mistake. It's not 7 and negative 20 anymore, 21 anymore, it's now positive 21 and 105. Now that I have this inverse, I actually stack these together. So I'm going to add them. That's where the word elimination comes from. We just eliminated x. Now for y, I have 24y minus 60. That's going to be, what do we get there? 36, negative 36. Right? Equals 126. And that's y. Don't panic, it doesn't seem like it goes in evenly, but this should work out pretty good, I think. We divide by the coefficient of negative 36, and we get, I think it's 3.5. 126 divided by negative 36, negative 3.5. Negative 3.5 works. Okay, now once we have one solution, we go back to the originals. We can choose either. I'm going to choose the bottom one. I'm going to plug in that answer that I just got carefully for y. I don't want to plug it in for x. And I'm going to use this to help me solve for x. Be careful here. Use your calculator if you have to. 12 times 3.5 should be 42, negative 42. Equals negative 21. Move the 42 over by adding it. You'll get positive 21, or x equals 7. So putting it all together, we have x equals 7, y equals negative 3.5. You can write it like this, or separately as a coordinate. Just be careful, use parentheses if you are doing the coordinate form. So this is our solution. Sweeney did just get a dog, so I'll believe it if he says he has some issues going on. All right, if you missed it earlier, we just said we're kind of going to break this down by the 6 topics. So that was pretty much the most straightforward one, just solving a system algebraically. You have 2 methods right away. I guess 3, graphic, substitution, or elimination. We all kind of discussed how elimination would be your best bet here because the coefficients are not 1. Obviously, you wouldn't want to graph this if you're given the choice to not do so. So elimination, create an additive inverse, solve for one variable, and substitute in to find the remaining. You can check by using matrices. I wouldn't recommend using matrices for the whole problem because obviously we want to show algebraic work. Matrices, there is a separate video on that. That's creating a 2x3 and just typing in the numbers, and then RREF, if you can remember that. All right, so next one. Again, we'll give some people some time to try this one. Came in late, orientation is locked for some reason, so I can't make this much larger. Oh, that's really small. All right, So this is our coin system. So this says you only have quarters and dimes. Let's say the value is $8.05. How many of each coin do you have if there's a total of 40 coins? So 2 pieces of information here, 3 I guess. You have quarters and dimes. You have $8.05 and a total of 40 coins. You only have quarters and dimes. The value is $8.05. How many do you have if there's a total of 40 coins? My handwriting is not that great here yet. All right, so we're gonna start by assigning variables here. I'll kind of zoom, I know it's hard to see. So we'll say let Q equal, what was it, quarters and dimes? Let Q equal the number of quarters that this person may or may not have, and D equal the number of dimes. So now the 2 pieces of information are the fact that I have 40 coins and $8.05. So the first one, probably the most straightforward, is just the fact that you have, I'm forgetting myself now, 40 coins. And they're used to say something to specify that it's just these 2 types. Because otherwise you could say, hey, quarters, dimes, pennies, nickels, and all that. So obviously we're not making this a 4x4 system. We're keeping it as a 2x2, 2 variables, 2 equations. So they'll say, hey, he only collects weirdly for some reason. This is just, I call it a number equation. All that's just kind of counting. And now we want to incorporate how much each coin is worth. So for quarters, we know that those are 25 cents. Numerically, that's 0.25Q. Dimes are 10 cents. Numerically, that's 0.1. You could put 0.10 if you like. 0.1 is equivalent. And that should add up to that money amount that we were given, $8.05. Okay. Now the first thing that I would do, a lot of people get kind of turned away with the decimals here. If we multiply this entire bottom equation by 100, basically moving all the decimals over twice, we can rid all the decimals nicely because it is money. There's 2 decimal places in each case. Not that this drastically changes anything. Like I said, a lot of people kind of get scared with the decimals. Maybe you're more apt to make a mistake if you're doing elimination with decimals than you are with just plain old whole numbers. So now we're there. And now, once again, we could do substitution or elimination. I'll do elimination once again. I'm going to eliminate D. So I'm going to multiply by -10. Notice how I have a +10 up top. That's why I'm choosing -10 on the bottom. That's going to be -400. If we add these together, we'll get 15Q. Our dimes cancel out. We get 405. You might want to write this separately. I'm kind of being lazy and creating like a triple here. Okay, and now if I divide by 15, I will find out how many quarters I have, which should be 27. Now the problem is very simple from here because we were told we had 40 coins. I already know quarters account for 27 of those, so how many dimes are missing? Should be 13. So you can be fancy and say, therefore, this person, let's call him Joe. Joe has 27 quarters and 13 dimes. So just to recap, we create our number equation, our money equation. You can eliminate the decimals by multiplying by 100. Just be careful. I have seen people make mistakes with trying to do something to help them not make a mistake. So go through the effort, I guess, of actually showing or illustrating that you're multiplying by 100. We use elimination. This one could work. It's 1Q and 1D. And then chose to eliminate dimes. You could have multiplied by -25. I'll usually eliminate. We get quarters, and then these usually very easy towards the end because you have that kind of simple equation. How many dimes were there? 13. So 27 and 13. All right, next one. I'll leave this one up. Just hit refresh because I'm gonna skip around actually. Let's try this one. So I'm gonna skip to writing a linear equation. I'm gonna fix this one. Hold on. So it's more convenient for our vertical viewing pleasure. So write a linear model that passes through those 2 points, -9, 2, and 3, -6. Now let's assume it also passes through the point k, -12. Find the value of k. So this is a linear function, so I'll give you a hint. And try, what the heck? Try not to use or just rely on linreg. Try to know how to do this by hand. Obviously showing work for tomorrow. There's no multiple choice, literally. Very important. Take a moment, try this one. Y equals mx plus b. I'm using 3 devices, my iPad, Apple TV, my phone is recording it, my laptop is how I'm looking at the video and chat. You can't record from your computer, so I have to use a phone. All right, take one more minute. Press 3 times in the home button. I don't have a home button. The chalk. All right, so let's see. So we literally need two pieces of information here to get this rolling. We need slope m and b our y-intercept. So we're going to start with m, our slope. I usually like to put this in a table form. I think it's easier, at least for me. And most of you guys usually agree to see it in a table versus the points. And we look at the change top to bottom. Not that the order matters there. I just think it's easier looking at it that way. And if you have trouble doing this, you can subtract. You could work backwards. You could say, hey, what's negative 6 minus 2 if you're not sure what that movement is. But this would be going down 8. I'm putting negative 8 because notice we went from positive 2 to negative 6, and that changes 8. Think about a number line. That would be 8 jumps to the left. Now from negative 9 to positive 3. We have a change of positive, we're going up 12. Now when we express this as a ratio for slope of delta y over delta x, that's going to be negative 8 over positive 12. Divide both of those by 4, and you get negative 2/3, just simplifying the fraction. So this is where we are so far. We did our slope, we got negative 2/3, and now we're just still missing that b value. So what do we do in this case? At this point, I should say. We use the points that were given to plug in. So I'm going to use the bottom one. It wouldn't matter if we chose the top one. I'm going to plug this in for x and this in for y. So we get negative 6 equals negative 2/3 times 3 plus b. Multiply here, we get negative 6 equals negative 2 plus b. Add the 2 to both sides, and you'll get b equals negative 4. Now just put it all together. Technically, we haven't written our equation yet. We knew the slope earlier was negative 2/3. We just found the y-intercept was negative 4. So this is our linear function. Y equals negative 2/3 x minus 4. You can double check this two ways. One way would be the lin-reg feature, which is stat L1, L2 under edit. Then stat calc lin-reg choice 4. You'll see negative 0.6 repeating here because 2/3 is 0.6 as a decimal repeating. The other way to check, if you type this into y equals, you should notice those 2 points when you scroll through the table. If I type this into y equals and I don't see 3 negative 6, I know I made a mistake somewhere. All right, and now the second question here. If it passes through the point, I'm just going to copy this. If it passes through the point k negative 12, what's the value of k? Take a moment to digest this a little bit. I guess taking like a 5th grade geometry quarterly is 700, 900% greater than 70. What? Yeah, I don't have an iPhone with a home button. I have an iPhone X. The orientation isn't on either. It's kind of like YouTube, how they let you record. Might have been how I set it up, which would be really weird that you can't change it. Feeling division. All right, so how we would do this, you could do it a few ways. You could utilize your calculator table. Algebraically, you know k is negative 12. It's basically a problem where you're solving for an input. You're solving for x. I would move 4 over. I get negative 8 equals negative 2/3 k. I'll multiply both sides by negative 3 over 2. The million-dollar question is why negative 3 over 2? With fractions, we multiply by the reciprocal because this happens. Everything cancels. I'm left with k, and these cancel. I get 4, negatives cancel. I get 12. Just double check, I didn't make a mistake there, very likely. And like I said, you can double check on your calculator utilizing the y equals feature and looking at the table. So we should see 12, negative 12. If we don't want to be fancy and make an algebraic mistake, yep, 12 works. So the point 12, negative 12 was on this graph, or lies on this graph. Once again, knowing how to do it by hand is very important. This way you can get some partial credit if you do make a mistake. All right. Next question, probably one of the more difficult ones because it's relatively new. It can be challenging at times. Looking at functions in three different formats: a graph, a table, and an equation. And you're going to be asked a few questions about this. Obviously, for the graph, you could probably bet, I'll zoom in a second, we're going to be asked domain and range. There's also this increasing, decreasing interval that's tricky for some of you guys. And obviously, with the table and equation, we could be asked to evaluate either for an input or for an output. So let's zoom in on the graph first. I think that should be nice and clear. We'll start by, so that's g, right? If we were asked something like g of 1. What would you guys say the answer to that is? I know it's hard to see. What is g of 1? What is g of 1? G of 1 for $1,000,000 is what? Two is correct, Jonathan. So that means when x is 1, what's the y value of the graph? 2. Okay. Conversely, let's look at that same question. So obviously we already know the answer. But if I phrased it like this, if I said, hey guys, where does g of x equal to? That's where we would say 1. That's me looking for, hey, what's the x value where it has a y value or an output of 2? Notice there's also another answer. So this will usually say, like, find all the values with that, like, weird plural thing. It could be another answer. So it looks like it's somewhere over here. Obviously, we don't know the exact value. So those will usually be more than 1. Now, this is where we get tricky. So let's start with the domain. What is the domain of this graph? So domain, just to illustrate what we're talking about, we're looking left to right, right? What's the left bound of this graph? X, Y's, in terms of X values. And what's the right bound of this graph in terms of the X values? So the furthest this graph goes to the left is -1. Now, why am I using brackets? Notice that that value is included. We see a nice filled in solid circle there. On the right, what's the right bound of this graph? Looks like, let's count carefully, 1, 2, 3, 4, 5, 6. 6, notice, is not included, so I'm going to put parentheses. When else besides open circles would you see parentheses? For anything that goes on till infinity, we always use parentheses, or negative infinity, or like I said, look out for open circles. Now, what is the range of this graph? Ranges are y values, so we're looking vertically. With domain, if we're looking left and right, range, we're looking up and down. So the smallest we go here is -2. The largest we're going to go up to is 1, 2, 3, 4, 5 to +5, including or touching +5. Okay, so be careful with domain and range. Know when to use brackets, when to use parentheses. Also know what you're talking about here. Alphabetical order applies if you start confusing these. Domain, D comes before R, just like X comes before Y. So domain, you're looking at your left and right X values. Range, you're talking about your up and down Y values, vertical. All right, and increasing versus decreasing. This was one I was in lesson 2, I believe, the second day after we came back from break. Excuse me, not after break, before. The Tuesday or Wednesday, we talked about graphical functions, whatever the date was, the 18th December. Increasing versus decreasing just has to do with the graph going up. So when I talk about an increasing interval, I'm going to highlight it on the graph just so you know what I'm talking about. The graph is increasing here. It's going up. If you want to define it another way, as a positive average rate of change. It's kind of like the beginning part of a roller coaster. So that interval, kind of like domain and range, but a little different, I'll explain why, is going to go from 0 to 1, 2, 3. Now, what's different about domain and range? Notice I don't have brackets on the endpoints here. It does go from 0 to 3, so you might be saying, why isn't it bracket 0, bracket 3? We treat 0 and 3 as kind of like a neutral. Now, decreasing wise, we have 2 answers here, so the test tomorrow will just say choose 1. I'm going to choose the second half here. It's obvious that we use parentheses. Again, we're going to use parentheses on the left. It goes from 3 to 4, 5, 6, from 3 to 6. So just be aware with increasing, decreasing, we use parentheses, kind of treat it like a neutral ground. And how do you find this? Very simple, look for slope. I think we could all kind of associate increasing with positive slope and decreasing with negative slope. All right, looking at the table. Take a moment. I'm just gonna kind of catch my breath here. To answer these, h of 3, where does h of x equal 3? And then h of 1. See if you can answer these 3 questions. All right, so h of 3, this is telling me, hey, when x is 3, what's the y value? You should answer -5. Where does h of x, sorry, that should say equal 3. So where does this function have an output of 3? What's the x value where this function equals 3? The answer to that would also be -5. Probably a bad table I set up here. Because really, we happen to get lucky if you made a mistake, but for this question, we were looking here. And for this question, we were looking here. So notice they happen to be the same answer, but 2 totally different rows. And the last one, h of 1, this is important where we look. We're looking right here. Hey, when you input 1, what's the output? The answer should be -9. All right, and last one, something like this. So let's say, hey, where does, what does f of 4 equal, let's say? And then where does f of x equal -9, let's say. Does that work? Yeah. Take a moment. All right, so for f of 4, that's us plugging in a 4 for x. It should be 4 times 4, 11, 4 times 4 is 16, so 11 minus 16, we should say -5. For the bottom one, where does this function equal -9? So I'm literally going to set the rule equal to -9. I'm going to move the 11 over. I get -20 equals -4x. Divide both sides by -4. Negative divided by negative, I should get +5. So know the difference basically with functions. This is kind of like functions 101. Know the difference between inputs and outputs. All right, quickly, I think we got 2 more. Yeah, okay. So modeling with, I call this an adjustment function. So hey, you have a cell phone plan, you get 4 free gigabytes with your monthly payment of $15. So basically like, hey, you just paying your phone bill, you get 4 free, which is usually the case. I think most carriers are like 2 free gigabytes if you don't have unlimited, which pretty much everyone does. And then every extra gigabyte after that costs $12. So we're going to model this with a function. Let's call it C of x. So how much are customers paying each month? And let's assume that they go over. Otherwise it would just be 15. This would really be a piecewise function. Hey, it's 15 bucks if you don't go over, and then some other rule. But let's assume they go over. So that would be $15. They're paying their monthly bill. Plus, they're going to pay $12 for each gigabyte. Let's call gigabytes x here. So it's not this. This is incorrect. Right? Because this would be assuming, hey, if they use, let's say, 5 gigabytes altogether, that they're getting charged $12 for 5 gigabytes. That's not the case. Because 4 were free, because 4 were free, in parentheses, we want to indicate that we're really only being charged for 4 less than however many we use, or x minus 4 times 12. Now, one thing you can do, if you want to be fancy, obviously you can distribute this. And you can alternatively write this function as 12x minus 33. This top line and this bottom line are both acceptable. I don't know why you would stop at that middle point of saying the same thing. This way I plug in something. You might see a follow-up for this tomorrow. So hey, someone spends, I don't know, some amount, $104. How many gigabytes did they use? So you plug in for C of x, that amount. How much would 15 gigabytes cost someone? So plug in 15 for x. So usually you'll see some follow-ups tomorrow. And last one, most importantly, graphing inequalities. So really quickly, we're going to graph the system of inequalities. X is greater than -4. And that second little rule there, we're going to label the solution set S. So I'm going to start, I'll do this one in purple. This is not a piecewise rule. This is a vertical line, and it's also dotted through -4. How do I know it's dotted? It doesn't have a little equal to line underneath it. So right through -4. Okay, and now where am I shading here? We usually say like above and below and stuff like that. Vertical lines, obviously we can't, but use some common sense. If x has to be greater than -4, we're shading to the right. And right away, I want to label here. X is greater than -4. So I don't forget, I'm already good labeling wise, technically. For the bottom one, I got to do some extra work here. I'm going to get it in Y form. I'll do this in blue. I'm going to subtract 4x to start. I'm going to divide both sides by -5. Since I'm dividing by a negative, my sign less than or equal to becomes greater than or equal to. It flips. 4/5 negative over negative, x minus 4. With inequalities, I make 4 bullet points. M, B, what type of line, and where to shade. So our slope, we got 4/5. our y-intercept, we got -4. This is going to be a solid line, the little or equal to, and this is going to be above. For those of you that get confused with where to shade, I usually say read the inequality out loud. In this case, you'd say greater than. That usually associates above, or the word above. So I'm going to begin at -4. I'm going to move up 4 over 5. Move down 4, 1, 2, 3, 4, back 5, 1, 2, 3, 4, 5. Doing a solid line. I could label this if I like. Technically, you only have to label 1 with the system. And this is being shaded above. If you're curious why wasn't it below, if it looked like less than in the original problem, we did flip the sign. And now this gets shaded above. Remember with shadings, touch the actual line itself. Don't color in a million boxes. Just have a few lines jutting out. Okay, now I'm looking for where these shadings overlap. The most important part, where this S goes, this whole little triangular slice here is S, my solution region. So quite a large one. And last thing we want to do here, we want to show that 8, -2 is not a solution. So one way I could do that, 1, 2, 3, 4, 5, 6, 7, 8, -2. It's right here on the graph. So obviously it's only in the purple shaded region and not the blue, therefore not a system solution since it only satisfies 1. I could also do this algebraically. So obviously it satisfies the x inequality. However, it fails, it has to fail, based on what we just saw, the other one, since it's not in the blue region, blue solution region. 32 minus or plus 10 with the double negative. 42 is not less than or equal to 20, so therefore not a solution. Doesn't satisfy, keyword, both inequalities. So just a recap from earlier. Some of the topics that we talked about: graphing a system of inequalities, writing a linear model, functions and function notation type stuff, modeling what I call adjustment functions, basically those parentheses and knowing that you have to account for that. These are usually things like cell phone plans, payment plans for taxis, payment plans for parking spots, things like that. A coin system, you'll see that tomorrow. Be aware of coins. We're talking about quarters, dimes, nickels. We've never seen pennies really. Using elimination or substitution once you set it up. And the very first thing we talked about, but the last thing, solving a system algebraically. That's the most straight up question on here. I'd probably start with this one if you're looking through the test. There are 6 questions, so make sure you pace yourself accordingly. That leaves, exactly 7 minutes per question, I suppose, if you start at the very beginning of the period, which is not a lot of time for some of these harder questions. So make sure you pace yourself. 6 questions sounds very easy, but it could also be a little overwhelming, being that they're all written and contain multiple parts. Any last minute questions? Math team thing, no. This is over. You can feel free to watch this again. I'm aware how to turn off the orientation on a phone. However, this is not being very user-friendly. All right, guys, thanks.